Previous classes we have discussed about sequences progression and arithmetic progression. In this class we are going to discuss about geometric progression. तो एपी में हम लोगों ने देखा था कि हर एक टर्म को हम कॉमन डिफरेंस से ऐड कर दे रहे हैं, ठीक है, और फिर जो रिजल्टिंग नंबर मिल रहा है उसमें अगेन हम कॉमन डिफरेंस को ऐड कर रहे हैं, फिर जो हमें रिजल्टिंग नंबर मिल रहा है उसमें अगेन हम उसी कॉमन डिफरेंस को ऐड कर रहे हैं, ठीक है, और ऐसा कंटिन्यू होता जा रहा है. सो इन ज्योमेट्रिक प्रोग्रेशन वी आर नॉट गोइंग टू ऐड समथिंग, वी आर नॉट गोइंग टू सब्ट्रैक्ट समथिंग, we are going to multiply a common number, and that common number is known as common ratio, and it is denoted by your alphabet letter R. So let's see. Suppose your first term is A. Okay, it is taken as A. Your first term of GP is taken as A, and we are multiplying a common number with a common number. Why I am saying it a common number? Because in each of the term that common number is being multiplied. So if this is A, we are going to multiply A with R, so the resulting number will be AR. Again this number is going to be multiplied by R, so it will be AR square, again with R, so it is going to be AR cube, and so on. So its nth term will be AR to the power n minus 1. Okay, so this is a important formula. Tn equals to a plus n minus 1 into Tn equals to a into r to the power n minus 1. Okay, let's observe an example like 2 to the power 2, 2 to the power 3, 2 to the power 4. This is in GP, and if someone asks you that find the 8th term of this geometric progression, so you have to write T8 and you have to apply this formula ARn minus 1. A is your 2, A is your first term, so your first term is 2. Common ratio is the constant number by which each term is multiplied, so 2 is multiplied by 2, then only you are getting 2 to the power 2, so it will be 2. And n is your 8 because you have to find the 8th term, so 8 minus 1 is 7, so it is 2 into 2 to the power 7, that is 2 to the power 8. This is your answer. This is how you have to find any term of a geometric progression by applying this formula. Okay, so before this I need to tell you that how to find this common ratio. Okay, so suppose you are having your GP is A, B, C, D, E. This is your GP. So your common ratio is going to be second term divided by the first term, that is B upon A. Okay, and this B upon A is also equal to C upon B. This is equal to D upon C. Okay, it is also equal to E upon D. Okay, so like this it will be continuing. Now next property, if your GP is AR square, AR cube, okay, and you are multiplying your GP with a constant, your each term of GP with some constant, okay, like A into K, AR into K, AR square into K, AR cube into K, and so on. So this is also going to be in GP. Suppose you are having 2 square, 2 cube, this is your GP, and you are multiplying it with some constant 3, so it is 3 into 2, 3 into 2 to the power 2, 3 into 2 to the power 3. So this group of number is also going to be in GP, and same case is there with division of each terms of GP with some constant. Suppose you are having the same GP and this GP is divided by some constant k, like a divided by k, ar divided by k, then ar square divided by k, means you have to divide each term of gp with the same constant. Okay, then this resulting this resulting group of number is also going to be in gp. You can take example and you can divide those gp with some constant, and you can observe it yourself that whether the group of number which you are getting after dividing it with the constant is in gp or not. Okay, प्लीज़ कीप वन थिंग इन योर माइंड दैट हमने एपी में पढ़ा था कि हम अगर एपी के हर एक टर्म को किसी भी कांस्टेंट से ऐड करें, सब्ट्रैक्ट करें, मल्टीप्लाई करें या फिर डिवाइड करें, तो हर एक केस में जो रिजल्टिंग ग्रुप ऑफ नंबर्स होगा वो सभी के सभी एपी में होंगे. बट इन ज्योमेट्रिक प्रोग्रेशन द सीन इज़ डिफरेंट. व्हाट हैपन्स इन ज्योमेट्रिक प्रोग्रेशन इज़, अगर हम ज्योमेट्रिक प्रोग्रेशन के सभी टर्म्स को किसी कांस्टेंट से मल्टीप्लाई कर रहे हैं या डिवाइड कर रहे हैं, देन ओनली those resulting group of numbers are going to be in GP. अगर हम ज्योमेट्रिक प्रोग्रेशन के हर एक टर्म को किसी कांस्टेंट से ऐड कर रहे हैं या फिर सब्ट्रैक्ट कर रहे हैं, देन इन दैट केस द रिजल्टिंग ग्रुप ऑफ नंबर इज़ नॉट गोइंग टू बी इन GP. सो ये ध्यान रखना है कि ऐसा सिर्फ ये वाला जो चीज़ है ये केवल मल्टीप्लिकेशन और डिवीज़न के केस में होता है, एडिशन और सब्ट्रैक्शन के केस में नहीं होता है. मतलब कि अगर हम जीपी के टर्म्स में किसी कांस्टेंट को ऐड कर रहे हैं या सब्ट्रैक्ट कर रहे हैं तो वो जो रिजल्टिंग नंबर हमें मिलेंगे वो जीपी में नहीं होंगे. ओके, नाउ लेट्स मूव ऑन टू आवर नेक्स्ट पॉइंट. इफ T1, T2, T3, T4, Tn are in geometric progression, then log of T1, log of T2, log of T3 up to log of Tn, these are going to be in AP. Okay, next point. AR square, AR cube and AR to the power n minus 1. If you want to sum all these terms of the GP, then the formula of calculating is A into 1 minus R to the power n 1 minus R, or A into R to the power n minus 1 upon R minus 1. Okay, and what is the condition? The condition is R should be greater than 0. If your R means if your common ratio is greater than 0, then only greater than 0, and also R should not be equal to 1. If this condition is true with your common ratio, then only you can apply this formula for calculating the sum of a GP. If your R is let's say minus 1 by 2, then you cannot apply this formula because R is less than 0. Okay, so what we are going to do when our R is less than 0? So there is another formula for Sn, and this Sn we have to use when our common ratio is less than 1, when our common ratio is less than 1 but greater than minus 1, means that our common ratio has to be in between minus 1 to 1. Okay, in that case our Sn is going to be just simply A upon 1 minus R. Okay, and if our R is equal to 1, then Sn is simply going to be n times A. Okay, so sometimes a GP is given like this. A AR square, and we don't have any finite term. It's written up to infinity, that it is going to that it is not going to stop at any of the term. Okay, it is going to continue on up to infinity. So in this case, your Sn is going to be a into 1 minus r. Okay, let's move on to our next property. Our next property is any three consecutive terms of a GP can be taken as. Okay, so we have to take any three consecutive terms of GP, then we can take those three consecutive terms as a into r, and a upon r. Okay, any four consecutive terms, in this case we are going to take a r cube, a r, then a upon r, a r, and then a r cube. Okay, again 5. See, in odd number of consecutive terms we will always have to take this a. ओके और फिर a के आजू बाजू में a r, then a upon r, then a r square, then a r square. Okay, we have to do in this way, and whenever there is even number of consecutive terms, then you don't have to take this a. You directly have to start with ar, and then ar cube, and then ar cube, and then ar5. See, the power is in odd terms. Okay, just observe the pattern, how is it taken, and here will be a upon r to the power 5. And then in 8th term, what will be in 8th term? So just you have to add a r to the power 7 and a upon r to the power 7. Okay, and if it is 7th term, then simply you have to add a r to the power 3 and then a upon r to the power 3. In GP इक्विडिस्टेंट टर्म्स का प्रोडक्ट इक्वल होता है. ओके, सो इफ यू आर हैविंग ए आर स्क्वायर एंड हियर यू आर हैविंग a r n minus 3, a r n minus 2, a r to the power n minus 1. Okay, can you see? N minus 1. Then if we are multiplying this first term with last term, second with second last, third with third last, fourth with fourth last, then all the product of those numbers are going to be equal. Like a into a to the power r to the power r minus 1 is going to equal to a r into a r to the power n minus 2, and this is also going to be equal to a r square into a r to the power n minus 3. Okay, you can calculate it. A square r to the power minus 1, then again a square r to the power n minus 1, again a square r to the power n minus 1. So you can see that in each of the cases the answer is a square into r to the power n minus 1. One more very important property is, if a, b and c are in GP, then b square is going to be equal to AC. Okay, let's prove it. No, we are not going to prove it, we are just going to see whether this holds true or not. So let's take 2, then 4, and then 8. These three are in GP, so assume it as A, B and C. if this is in GP, if 2, 4, 8 are in GP, then B square must be equal to AC. So B is R4, 4 square should be equal to 2 into 8. So you can see that 16 is equal to 16. Hence this is true in the case of GP. Okay, so one more property is there. Okay, it's not that much important, but if you feel that you should keep in your mind, then you can keep in your mind for sure. Okay, so if A, B, C are in GP, then B minus A upon C minus B is equal to A upon B. Okay, you can see that if we cross multiply, B square minus AB is equal to this one, AC minus AB. Okay, so AB and AB gets cancelled out, and we are again left with B square equal to AC. Okay, so if you want to learn it, you can definitely learn it, otherwise you can leave it also. सो आज की क्लास यहाँ पे ख़त्म होती है. मैंने ज्योमेट्रिक प्रोग्रेशन के जितने भी इम्पॉर्टेंट पॉइंट्स थे उनको थोड़ा शॉर्ट में बताने की कोशिश की है. इसके बाद आप ज्योमेट्रिक प्रोग्रेशन के क्वेश्चंस को सॉल्व कर सकते हैं. इतनी ही प्रॉपर्टीज़ थी. नेक्स्ट क्लास में हम हार्मोनिक प्रोग्रेशन के साथ मिलेंगे.